Hello, dear students. You all are welcome to the class of numerical skill. Our topic for today it is matrix multiplication. We already discussed about the rules and procedure of multiplication of two matrices. So let us check how to solve a specific question. So first, let's see the question. If A is equal to 2, 3, 4, 5, 7, 9 minus 2, 1, 1, then B is equal to 4, 0, 5, 1, 2, 0, 0, 3, 1. For the square matrices, 3 into 3 square matrices. So the question is, you want to verify that AB transpose is equal to B transpose into A transpose. So the question is clear. You want to check it is again. We need to find AB transpose. So A into B transpose equal B transpose into A transpose. So before going to the answer, we need to find whether the given matrices can be multiplied or not. So we already discussed the rule of multiplication of matrices, that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So number of columns in the first matrix it is 3, and the number of rows in the second matrix it is 3. So both are equal. As it is equal, it is multipliable. We can multiply the given matrices. So before starting the question, we can check what are the things we need to do. So first, we need to find A into B so that it is AB. Then second, we need to find the transpose of AB. Then only first part can be calculated. Transpose of AB. Then third one, we need to find transpose of A and the transpose of B. Then fourth one, we need to find the product of B transpose and A transpose. B transpose into A transpose. Then the last stage, we need to verify both the answers are equal or not. So let's see how to do. The first one it is we need to find A into B. So here in the question A is equal to, this as per the question, 2, 3, 4, 5, 7, 9 minus 2, 1, 1 into B is equal to 405 120 031 equal. Multiplication we know. We need to multiply the each row with all the columns. Each row must be multiplied with all the columns of the second matrix. So let's see the answer. So first row it is 2, 3, 4. We need to multiply it with the first column of B. We already discussed it in detail in the previous video. So if you have any doubts, check the previous videos how to find this one. So here it is 2 into 4, it is 8 plus 3 into 1, 3 plus 4 into 0, 0. Then again first row with the second column, 2 into 4, first row with the second column. So 2 into 0, 0 plus 3 into 2, 6 plus 4 into 3, 12. Then again first row with the last column. 2 into 5, 10. 3 into 0, 0. Then 4 into 1, 4. So just like all other things. The last one, let's check. So last one means last row with the last column. So minus 2 into 5, minus 10. 1 into 0, 0. 1 into 1, 1. So find AB. AB is equal to 11. 8 plus 3, 11. 6 plus 12, 0 plus 6 plus 12, 18. 10 plus 0 plus 4, 14. So like 27, 41, 34, minus 7, 5 and 9, minus 9. So we need to find AB transpose or transpose of this one. Transpose we know it is a result of resultant matrix. We got it by interchanging the rows with the columns. So if you interchange this matrix by its rows with the columns, we will get the transpose. So let's see the answer. It is the first part of this question. AB transpose is equal to, here 11, 18, 14. It is the first row. So we took it as the first column, 11, 18, 14. Then 27, 41, 34. It is the second row here. It is the second column here. So we interchanged all rows with columns. So this is the first part is over. Then we need to do the second part. Transpose of B into transpose of A. So first we need to find the transpose of A. So A we know as per the question it is like this. A is equal to 2, 3, 4, 5, 7, 9 minus 2, 1, 1. Then transpose of A is equal to 2, 5 minus 2, 2, 5 minus 2. That is, we are interchanged all the rows with the columns. Here the first row is 2, 3, 4. So here the first column it is 2, 3, 4. So like that, the transpose of A. Then B is equal to, it is as per the question B, 405, 120, 031. So we need to find transpose of B. Means we need to interchange all the rows with its column itself. Transpose of B is equal to 410. 410 is the first row here. Here it is the first column. Here the second column is 023. Here the second row it is 023. So we exchanged all the rows with the columns. So we need to find this one. The transpose of B into transpose of A. So we at present we have A transpose and B transpose. So find the product. Multiplication we know. So transpose of B into transpose of A is equal to, so this is the B transpose, 410, here it is, 410, 023, 501 into A transpose. A transpose is this one, 2, 5 minus 2, 371, 491 equal. So multiplication we know, we need to multiply the row with columns. So 4 into 2, 8 plus 1 into 3, 3 plus 0 into 4, 0. So like that. First row with the second column, here it is. Then first row with the third column, here it is. Then the last one, last row with the last column. That means 5 into minus 2, minus 10, 0 into 1, 0 plus 1 into 1, 1. So the answer will be, it is 11, 8 plus 3, 11, 20 plus 7, 27, minus 8 plus 1, minus 7, 6 plus 0 plus 6 plus 12, 18, 0 plus 14 plus 27, 41, like 5, 14, 34, and minus 9. So both the terms we found now, then we need to verify whether both are equal or not. That means AB transpose, then transpose of B and the transpose of A. So AB transpose is equal to 11, 27 minus, which is in the first slide. We already calculated it. Then B transpose into A transpose is equal to this one. Just now we calculated. So look here, both are equal. So we can say that it is proved that AB transpose is equal to transpose of B into transpose of A. So this is the mode of doing this type of question. Okay. Thank you. Thank you all.